All right, today we're in section 9.3, the Pythagorean Theorem. The Pythagorean Theorem can only be used with what kind of triangle? Does anybody remember? No? No? A right triangle. The triangle has to have a 90-degree angle. So it can only be used in a right triangle. It is only true if it's in a right triangle. You need to know that the legs form to make the right angle. So you can see in the picture that the legs of the triangle will form to make the right angle. Those variables are A and B. Those are interchangeable because you can add in any order, okay? So if it's 3 plus 5 or 5 plus 3, it doesn't matter. The legs can be interchangeable, but the hypotenuse, side C, has to be by itself on the right side of the equation, okay? So the hypotenuse, we've got to get it on the other side of the equation. And sometimes you might be solving for A, sometimes B, sometimes C. You just have to see what information the problem is giving you. Another hint for hypotenuse is that it's always opposite the right angle. Okay, so the legs form the right angle and the hypotenuse is always opposite the right angle. So the formula a squared plus b squared equals c squared is going to be the original problem on all of your homework problems tonight. Okay, so you don't have to worry about drawing the triangles or any of that. Okay, so in example 1, and I'm not really sure why they do this, but they start off with kind of large numbers. Well, the large numbers are okay because I'm using my calculator, all right, but they give us these values, all right. They said that the altitude, and it's actually a word problem. We'll just read that really quick from your book, so just kind of listen along with me. But this is actually a bridge, okay? So imagine if it's a cable bridge that extends actually across the Ohio River between Kentucky and Ohio. So this bridge, and you can actually see a picture of it in your book on page 465. It spans literally between two states. So what it's saying is the bridge is actually 212 feet high. That's pretty high. And it's 478 feet. Let's see, is it long? The bridge surface. Wow, so that's actually the surface of the bridge. Okay, so those are my dimensions, but really what it comes down to is I'm just going to use the Pythagorean theorem. All right, what would be the length of the cable? The length of the cable that has to attach. So you can imagine this cable attaches the top of the bridge with the surface of the bridge. So what is the length of the cable? Well, I just have to use the Pythagorean theorem. Since I know that it forms a right triangle, I can use the Pythagorean theorem to plug in my numbers. All right, so go ahead and make your substitutions. Just gonna pause real quick. All right, so what value did you plug in for A? 212. Then B is 478, and you don't know C. So we have to square each one of these terms. All right, so in our calculators, we're going to go 212 squared plus 478 squared. You should be putting these in your calculators. Hit equals. What number do you get? 273,428 equals C squared. All right, so this is my answer, right? This is my answer. Why? C, yeah, very good. C is not by itself. It's squared. So back in 11.1, we learned what do you do when you have a variable raised to an exponent. How do you get it by itself? You take the square root. All right. Now this is not going to be an even number. So the directions say to round to the nearest whole number. Round to the nearest whole number. So go ahead and take the square root and round to the nearest whole number. All right, so we'll pause real quick so you can get your answer. You got approximately 523 feet. Okay, so that's how long the cable is that extends from the top of the bridge down to the bridge surface. Okay, so just following this process. Now, example 2, I would say, is a more realistic problem as far as what you would see on a homework assignment. In example 2 now, we're solving for a different part of the Pythagorean theorem. So now it says find the unknown length A in simplest form. Again, you don't have to draw the triangle on your notes. What do you need to write on your notes? The formula. A squared plus B squared equals C squared. You say, well, I just wrote it in example 1. Okay, good. Now write it again. Okay, so we're going to use it for every problem that we work. And the more we write it, the more we're going to memorize it. All right, so A squared plus B squared equals C squared. Go ahead and try to make your substitutions. So let's pause again. So we make our substitutions. We're solving for A. Which value is B? Is it 10 or 12? It's 10. It forms the right angle. 12 is the hypotenuse because it's opposite the right angle. So plus 10 squared plus 12 squared equals 12 squared. Now, do I need my calculator for these? No, I can do 10 squared and 12 squared. All right, mental math. So A squared plus 100 equals 144. All right, now you have two choices. Your first choice is to take the square root first. So we're going to take the square root of A squared, 100, and 144. Or would the other choice be to subtract 100 from both sides? What do I have to do first? I need to subtract 100. I take the square root last, okay? So take the, subtract 100 from both sides to get 44. And now A squared equals 44. All right? So again, this is not my final answer. What am I going to do? Take the square root of both sides. 2 to the square root of 11. When you put it in your calculator, so go ahead and do that, okay? The square root of 44, when you put it in your calculator, that's the answer that it gives you, 2 times the square root of 11. Why did they pull the 2 out? Why is the 2 on the outside of the square root? This is what we learned yesterday. Why isn't the whole thing just, why isn't my final answer square root of 44? Okay, so 11's not a perfect square, so it stayed underneath. And if they pulled the 2 out, what did that mean about the factors of 44? Okay, but there was a perfect square, factor of 44. And if they pulled a 2 out, what does that mean the factor was? The square root of some number was 2 that they pulled out. So what was the perfect square factor? The square root of 2, guys. Or the 2 was the square root of 4. 4. Okay? So what they're saying is, guys, you've got to understand this. Why is the 2 outside? It's because 4, does everybody agree that 4 is a factor of 44? So 4 was a perfect square factor. So they pulled out the square root of 4. That's why the 2 is on the outside. But then 11 stayed inside. 4 times 11? 11 stayed inside because it has no perfect square factors. You see that? That's why 2 is on the outside. That was the whole point of what we did yesterday in yesterday's lesson. Okay, let's do a practice problem now. Okay, so again, we're just sticking with the same concept. All right, here's your triangle. I want you to find the unknown length. All right, so pausing again. Did you plug them in? Okay, so 20 for A, you don't know B, and 25 for C. So you just make your substitutions. Everybody there? All right, what's 20 squared?
400.
400 plus B squared equals 625, okay? Now what do? I take square root? Take square root now? What do I subtract? 400, both sides. Now B squared equals 225. We have this one memorized. We don't need calculators for this. What's the square root of 225? 15. Okay, that's part of our perfect squares that we've been memorizing. All right, now let me ask you this. anytime in 11.1 that we would solve an equation involving square root, my answer was positive and negative. Why is my answer not positive and negative here in this problem?
Because it's the square root.
No. If you were to plug in negative 15 in the formula, it still works out, but I can't have a negative. Why? Janie? Is that what you're going to say, Wame? It's measurement. It's the measurement of a triangle. You're finding side lengths. Well, a side length cannot be negative. So because a side length cannot be negative, it's just 15. All right? So that's the difference, because any other time when you're solving an equation, your answer has to be positive and negative. All right. Now I want to go over to a slide, all right, that talks about the Pythagorean Theorem. Okay? And what is a theorem anyway? Okay? And what does it even mean for something to be the converse of a theorem? Does anybody have an idea of what you think converse means? When it says converse of the Pythagorean theorem, what do you think that would mean? Anybody just have a thought as to what that sounds like? Very good. The opposite, or, you know, maybe the opposite order. All right, so here's the theorem that you need to write down in your notes. If a triangle is a right triangle, then a squared plus b squared will equal c squared, which means, here's what it means. You see any right triangle, okay? What it means is the lengths of the legs, if you square them, will be the same value as the length of the hypotenuse. It will always be that way. That's what this theorem is saying. So if you reverse those two parts of the statement, you can actually test whether or not a triangle is a right triangle. If a squared plus b squared equals c squared, then the triangle is a right triangle. So what if you didn't have the diagram of the triangle? What if all you had was, what if all you had was the lengths of the sides and it said, is it a right triangle? Well, you can use Pythagorean theorem to test the side lengths. If they equal, then yes, it's a right triangle. If they don't, then it's not. Okay, so you can use this to determine whether or not a triangle is a right triangle. That's what we're about to do. All right, just pause it real quick so everybody can finish writing that down. All right, so let's look at example 3. All right, in example 3, now all I have are side lengths. A equals 3, B equals 5, C equals 7. So I'm going to plug them in. Here's what it's saying. These are my side lengths. Do these sides form a right triangle? Well, again, going by my theorem, the converse of my theorem, if a squared plus b squared equals c squared, then it is a right triangle, so I can test it. A squared plus b squared equals c squared. Plug in my values. 3 squared plus 5 squared equals 7 squared. I want you to simplify that. Simplify the left, simplify the right. Do they equal? Don't say it out loud. Write it on your paper. All right, so let's pause to work this out. Okay, so 9 plus 25. 3 squared plus 5 squared. What's 9 plus 25? 34. Does that equal 49? No. So, no, those side lengths do not form a right triangle. Go ahead and do the second one now. A equals 15, B equals 8, and C equals 17. All right, so let's pause to work that one out. Okay, so 15 squared plus 8 squared equals 17 squared. 225 plus 64, does that equal 289?
Yes.
So you say yes. Yes, the whole word, yes, not a Y, not an N. The whole word, yes, not a check mark, okay? So I just want to see definitively that the answer is yes. All right, if you understand that, that's everything you need to know for section 9.3.